Good afternoon. It's Wednesday, and I guess this would be September 11th. We're going to be looking at functions today, testing whether or not a function is a one-to-one relationship, and looking at vertical line tests, and actually looking at evaluating functions. So there's about 3 new things today. Only one of them is a little bit more challenging, but it's really just substitution. So I anticipate that you will handle it quite well today. So let's take a minute and take a look at this graph. So again, it's time and distance. I'm going to pause here for a second. I want you to write down, sketch this graph and write down a possible story about what is happening. Okay, so based on what we talked about yesterday, we know that home should be distance 0. So this is definitely home. We know that a flat part means we stopped. So hopefully you came up with a scenario where perhaps I was at my cousin's house and we drove to the mall, and then we spent some time at the mall shopping, and then my cousin and I drove home. That would be an approximate description of what's happening here. So hopefully you have something that talks about stopping and that you ended up at home. If not, please pause here and take some notes so that you remember what those 2 pieces mean. Okay, let's check some homework. So you were doing 9, 10, and 11, which were the graphing, mapping, table, and set notation. Remember, you needed to do domain and range. So I did not graph these, thinking that we probably don't need help with those. But your maps should look similar to what's up here on top. Okay? Remember, we do not duplicate numbers. So you're never going to write the same number twice. Make sure that you do not have duplicates on number 11. Like, we know that there's 2 -3s here, but we do not duplicate in the map, okay? That is why there's 2 arrows going to the -3. Do not duplicate the numbers. Same thing in your domain and range. We do not duplicate the numbers, okay, in our domain and range. However, domain and range need to be in set notation and from small to big. From small to big. So let's go ahead and pause here, and you can take a look at your answers and make any adjustments. If you have that 5, 5 on there, please make sure and just cross that guy out. The best answer is going to not have that duplicate 5. I'm going to be looking for that on your test next week, where they're in order and there's not duplicates. So, and you have set notations, you have the symbol. So pause here, take a look at your homework answers. Okay, so talking about 21, 22, 23, the independent variable is, of course, my x, so it's the number of dogs walked, and the y, the dependent, is the amount of money earned. So hopefully you came up with some sort of statement that the dog walker earns $5 for walking every dog, or every dog they earn $5. And point B, 5 and 25. Okay, 5 and 25. I walked 5 dogs, I made $25. Point A, I walked 1 dog, I made $5. So those kind of all go together. That one should have been pretty simple. Okay, looking at 24, 25, and 26, I have years since 2000 and sales in millions. So the independent variable is obviously my time. There's my independent. That's years. My dependent is sales. So if I'm looking at point D, that in 2005, it'll be 5 years past 2000, I would have made $6 million. But if I look at point C, that's 2003, I made $2 million. So make sure that you are identifying that these are the years past 2000 and what actual year that is. If I look at 27, all I needed to do there was use my X and my Y and develop my ordered pairs. And again, my domain is my X's, my range is my Y's. Remember that they have to be in order. Okay, 32, a triathlon. So if you're not familiar with a triathlon, that is where they swim, bike, and run. And they start out by swimming, and then they have to run up to where their bike is housed, change into their shoes, take their swim cap off, their goggles off, jump on the bike, go ride their bike, and then they come back. They take their shoes off, put the bike away, change into their running shoes, and then take off. So if you take a look at these graphs, the only one that really shows the points where they're stopping and transitioning, which means they're changing into their correct gear, so changing out of their swim gear into their, they're putting their bike shoes on and taking their bike shoes off and putting their tennis shoes on to run, is going to be B. There's 2 stopping points there in terms of distance. Okay, so I'm going to take a minute and I want you to pause here and I want you to write some vocabulary. I want this written down. I want this drawn in your notes, and I want this written down. So pause here and let's copy those 3 things. And then we'll do eyes up and talk about it. All right, so today we're looking at special relations that are called functions. So a function is a one-to-one relationship between x's and y's, which means for every x there is only one y, okay? Only one y. So there is no duplicate in the x's. So I cannot have the same number in the x's. I can't have 2 lines from the x's in a map. I can't see the same number twice in the x's. The y's don't matter. The x's matter, so no duplication of the x's. So if I take a look at this, the reason that this is not a function is because of this. There are 2 lines coming from the A. So this ordered pair would be A2 and A4. This cannot happen, okay? I cannot have 2 of the same x variables or values. I have to have different numbers in the x's. The y's don't matter. The x's matter, so this would not be a function. Functions have to be one-to-one. So let's take a look at this next one. 0, 5, 10, 2, 3, 4, 5. What do you think? Function or not a function? Hopefully you decided, nope, that's not a function because it has duplication in the x's. What about this one here? Notice how it has 2 arrows going to the C. Well, if I look at what that is as an ordered pair, I have 2C and 3C. I don't know that that's really a problem. Let's look at the domain. So the domain, 1, 2, 3, and my range, A, B, C, and D. I don't see any duplication. There are nothing here in the domain that is duplicating. This is fine. This is the y's. So this is a function. Okay? It is a function. It is fine to have 2 arrows coming to the C. I just can't have 2 arrows coming off the same number in the x. So again, a function is every x only has one y. No duplicates in the x's. All right, vertical line test. This is a really easy test to see if a graph is a function. So I want you to put your pencils down for a second, and we'll take notes here in just a minute about what a function versus not a function is with a vertical line test. So the vertical line test is just that. It is drawing a vertical line on the graph. And the rule is the line can only cross the graph once to be a function. Okay? And we know a vertical line is an up-down line, goes from top to bottom, and it's like laying a ruler on the graph. Notice how if I look at this line, it's only touching once. That is a function. Okay? Look at the red line. The red line only crosses the blue line once. This is a function. However, if I look at this one, it's crossing 3 times. It is not a function. Okay, it is not a function. Let's keep going. Or take a look at this one. If I draw a vertical line here or here, it's only touching once. So this one is a yes. Draw a vertical line here. That one's a yes. Draw a vertical line here. That's a yes, only touching once. Draw a vertical line here or here. Yes. And, oh, this one's a little bit different. Notice how it touches twice. So that one is not a function. A circle is not a function. Now this one is interesting because if I do it here, I'm touching once, but if I do it here, it's touching once. But if I draw it right here in the center, it's not touching anything. So I have to touch once to be a function. So that one is actually not a function because it's not touching. So let's take a second and I want you to write down the vertical line test that it can only cross once to be a function, and draw yourself a couple of examples of a function versus not a function so you can remember how the vertical line test works. So again, pause here, take a minute, write down some notes on what the vertical line test does and how it works. All right, let's talk about function notation. So at this point, I just want your eyes up and let's talk about how functions work, what they are, and how they really are just substitution. So function notation is really just another way to write an equation, okay? So we've seen things like y equals 2x minus 3. That's a linear equation. I know that it has a slope and a y-intercept, mx plus b, not a big deal. The only difference between an equation and function notation is the f of x replaces the y. There is no difference, okay? There is no difference. It's just fancy substitution. And okay, sorry about that. That's what happens when you're making a video. Okay, so function notation, again, there is no difference between an equation and a function notation except for the notation. So f with the parentheses and the x. So we read this f of x. So let me erase that here and write that a little bit better. F of x. This one would be read g of x, h of y, c of k. The only thing that has to happen is these two letters have to match. Okay? Otherwise, they can use any letters they want, but they're read f of x, g of x, h of y, c of k. And again, function notation is just substitution. All right, let's take a minute and write these two problems down. We're going to go ahead and evaluate these and figure out what's going on. So it says we have to evaluate. Remember, evaluate means we have to come up with a numeric answer. Okay, we have to come up with a numeric answer. So we have to come up with something like 5 or 12. Okay, so it's telling us that f of x equals 2x minus 3 and find f of 4. So this right here is telling me let x equal 4. Okay, let x equal 4. So that means this has to go in for x. Notice the math happens on the right-hand side, not the left-hand side, the right-hand side. So we know when we substitute, we use parentheses. So I'm going to put in parentheses for the x, put in my 4, and I'm going to evaluate. So 2 is 8, 8 minus 3 is 5. Okay? So my solution to this problem would be f of 4, which means I put in 4, and that equals my solution of 5. So this is the best notation to write your answer in. Okay? Tells me what I substituted in and tells me what the solution was. All right, let's look at it. So g of y equals negative 2 parentheses y plus 6. The negative 2 has to go into the math side. So I have negative 3 and negative 2 plus 6. Again, follow your order of operations. So I know this is a 4. Negative 2 plus 4, that's going to give me a negative 12. So g of negative 2, my solution is negative 12. Pause here, get caught up on your notes. All right, let's keep going. Take a minute and go ahead and start to solve these. I will catch up with you shortly. Pause here, give time to work. All right, plugging in negative 3. 4 times negative 3 minus 3. Too many negatives there. So this is negative 12 minus 3. That's going to give me a negative 15. So h of negative 3 equals negative 15. The next one, notice I have a power. So 2, I have a power. Put in your negative 3. Remember, anything to a power of 2 is positive, so that's 2 times 9. Negative negative is positive, that's 9. So 18 plus 12, that's going to give me a 30. So g of negative 3 is 30. Okay, now the next one looks like it might be pretty challenging, but in actuality, we're going to get an expression for an answer, not a numeric answer. In this case, because I'm substituting in variables. So I have 2, put in my x plus 1 for the x, and minus 3. To simplify this, I know I have to distribute to 2x plus 2 minus 3. Combine your like terms, 2x minus 1. So f of x plus 1 equals 2x minus 1. So again, you can get expressions for an answer like this one if you are substituting in variables, okay, into your answer. Take a minute and get caught up on notes. All right, let's take a look at these next couple here. This one's interesting. Let us have a plus 1 here. So if I think about what this means, it says find f of negative 3 and then add 1. So that means I have to do this part first and then take my answer and add 1. Okay? So negative 4 times negative 3 plus 7, 12 plus 7, that's going to give me a 19. Well, so that's this part. So 19 plus 1, that answer is 20. So f of negative 3 plus 1 is 20. So anything that's on the outside, you do after you come up with an answer. So for example, if I had 2 f of negative 3, that would mean take the answer from negative 3 and multiply 2 times whatever this answer is. In this case, this would be 2 times 19, which would give me 38. Let's take a look at this one, because this one's a little different. So this one has 2, so let's find f of 2 plus g of negative 3. So this means I have to do 2 pieces. The first one I have to do is substitute the 2 into f of x, which is this one. So that's negative 8 plus 7, that's going to give me a negative 1. So g of negative 3, that's going to go into this one. Oops, I screwed up. Let's erase that. I'm supposed to be using these guys. Let's try that again. So f of 2, that's going to be this one. So negative 3 times 2 minus 2, negative 6 minus 2, that's negative 8. G of negative 3, that's using this guy. So 4 times negative 3, that's negative 12. So I have negative 8 minus 12, that leads me to a negative 20. So I'm just adding those when I get my answer. So f of 2 plus g of negative 3, that equals negative 20. Okay, let's use this time to kind of get caught up on some homework. Make sure you're doing your homework and asking questions of each other or shooting me a message. We will, of course, review a little bit before we have our test, which is coming up here pretty quick. So stay on top of things.